Hello, ladies and gentlemen. I am Kiran Bendigeri from Grafosyss IAS. In this video, let's look at the 6th standard, the Earth, 3rd chapter. Motions of the Earth. The Earth has two types of motions, namely rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. The axis of the Earth, which is an imaginary line, makes an angle of 66 degrees with its orbital plane. So this is 66 degree angle with its orbital plane, right? The plane formed by the orbit is known as orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. So we can see here is the Sun and here is the Earth. It is tilted, and the exposed part to the Sun receives the light. So this is the day, and the rest of the land which don't receives the light, here it is night. The circle that divides the day from night on the globe is called the circle of illumination. So the circle which is there, which divides day from night, is called circle of illumination. This circle does not coincide with the axis as you see in the figure. So this is the axis, this is the vertical line, which is the circle of illumination. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth day. The period of rotation is Earth's day. This is the daily motion of the Earth. So here inclination of the Earth axis and the orbital plane, which we just discussed, day and night on the Earth due to rotation. So rotation. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. So only this region will receive the sunlight, and it will remain warm. The other half would remain in darkness and be freezing cold all the time. So this will be hot and this will be cold. Life would not have been possible in such extreme conditions. So there will be opposite conditions, opposite extreme conditions. So then life wouldn't have been possible. The second motion of the Earth around the Sun in its orbit is called revolution. So till now we discussed about rotation. Now we are going to discuss about revolution. Revolution, it's around the Sun. It takes 365 days or 1 year to revolve around the Sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. So it actually takes 365 days and 6 hours. But for the sake of convenience, we are going to consider only 365 days per year. And 6 hours saved every year are added to make 1 day over a span of 4 years. This surplus day is added to the month of February. Thus, every 4th year, February is of 29 days instead of 28 days. Such a year with 360 days is called a leap year. So I hope you will remember this leap year, because 6 days are added, 6 4s are 24, and every 4th year that 1 day will be added, and February will become 29 days, and the whole year will become 366 days. So it is called leap year. So from the figure it is clear that the Earth is going around the Sun in an elliptical orbit. So that image, so let's go through Google Images. From this image we can see that it is an elliptical orbit. So so we can see from this image on 3rd January the Earth is near to Sun and it is called perihelion, and on 3rd July it is very far from Sun, that is aphelion. And equinox, we are going to discuss in brief later. Equinox, line of solstice, and perihelion and aphelion, right? Notice that throughout its orbit the Earth is inclined in the same direction. A year is usually divided into summer, winter, spring and autumn seasons. Seasons change due to the change in the position of the Earth around the Sun. To understand the Earth's inclination in the same direction, draw a big ellipse on the ground and take a flag with a stick. Stand anywhere on the line of the ellipse. Point your flag to a fixed point far away like on a tree top. Now move along the ellipse, keeping your flag always pointing towards that fixed point. In this way, the axis of the Earth remains inclined permanently in the same position. The revolution of the Earth and the inclination of the Earth's axis in a fixed direction cause seasons. You will see that on 21st June, the northern hemisphere is tilted towards the Sun. So remember, 21st June, northern hemisphere is tilted towards the Sun. The rays of the Sun fall directly on the Tropic of Cancer. So I hope you remember 23 degree north up to equator, it is Tropic of Cancer, and if it is 23 degree south, it is called Tropic of Capricorn, right? So on 21st June, northern hemisphere is tilted towards the Sun and sun rays fall directly. As a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the Sun are slanting. The northern pole is inclined towards the Sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. So you have to remember this point also. The north pole is inclined towards the Sun, so Arctic Circle, which is at the North Pole, receives sun rays continuously and daylight for 6 months. Since a large portion of the northern hemisphere is getting light from the Sun, it is summer in the regions north of the equator. The longest day and the shortest night at these places occur on 21st June. So the longest day, shortest night, that's on 21st June. At this time on the southern hemisphere, all these conditions are reversed. So it happens exactly opposite at the southern hemisphere. It is in winter season there. The nights are longer than the days. This position of the Earth is called the summer solstice. So on 21st June, it is summer solstice, right? On 22nd December, the Tropic of Capricorn receives direct rays of the Sun as the South Pole tilts towards it. As the Sun's ray fall vertically at the Tropic of Capricorn, a larger portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the earth is called the winter solstice. So you have to remember, winter solstice happen on 22nd December. South is tilted towards sun, right? And in summer solstice, north is tilted towards the sun. On 21st March and September 23rd, direct rays of the sun fall on the equator. At this position, neither of the poles is tilted towards the sun, so the whole earth experiences equal days and equal nights. This is called an equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is in the case on 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus you will find that there are days and nights and changes in the seasons because of the rotation and revolution of the earth respectively. So I hope you will remember these things. One more way by which I can explain you so that you people can remember it easily, by one point. So if you remember this one point, you can answer all those things and you can remember all those things properly. So what is that thing? Australia, which is at the Tropic of Capricorn. Tropic of Capricorn, it is at the south, 23° south, right? So Australia celebrates Christmas at summer, and America, North America, celebrate Christmas, that is that comes on December 25th in winter. So these are the 2 points. So what happens? Why does it happen? Winter solstice. Let's look at winter solstice. Australia celebrate Christmas during summer. Okay. So South Pole is tilted towards it. That's why they will get direct sunlight and they are having summer season, right? And the same way you can think of 21st June, summer solstice. And in these months, June to December, the middle month of June to December is September, and again December to June, the middle month is March. So in these months, March and September, the sun rays directly fall on the equator. So that is equinox. So I hope you guys remember by these points. That's all for this chapter. Thank you.